Dear colleagues, welcome to the internal seminar presented by the INP team. The subject of this talk is about the observation activities we are developing in our research duties at GSCOP Lab, namely the observation in collaborative situations. This talk has been prepared by Franck Pourroy, Guy Prudhomme and Cédric Masclet, myself, and I will be in charge of the presentation. The agenda of the seminar will be as following. First, we will make a quick reminder of the theme and the scientific topics we are addressing. In a second time, we will go more deeply on the specific research issues that might involve observation, and we'll illustrate with a few use cases that lead to observations. The third part is dedicated to the presentation of a typical process we can set up in the frame of a project hosted by the Mexico.fr platform, the one we are using for providing the service. Finally, we will conclude on the various opportunities of implementing observations and the benefits that the visionary guest visitors may find. The ID team, Integrated Design team, is divided in three groups with different competencies to address complementary aspects of integrated design. The product process integration is rather oriented toward formalization and the integration of knowledge along the product life cycle. Many expertise can enter in this field, for example, manufacturing, assembly, environment. On the other end, the product representation team is working on the information systems and the format of product representation. It involves computer-aided design, geometry, optimization, product data management, etc. For a deeper description, I will recommend our website and of course the first seminar we gave last year presenting the Grenoble-INP team. We will focus on the collaborative design team that developed scientific activities around the phases of the design process where collaboration and the collaborative environments between the various stakeholders is required or happens. About the collaborative environments, here are some items we are developing. The first is to understand and model interactions in collaborative design. It means at the level of actors of trade or enterprise. We are using some concepts like boundary objects, multidisciplinary integration, etc. We are also focusing on developing methods and tools for the intuitive design office. It is directly linked to the collaborative design action. The visualization as needed for design process efficiency is relying on augmented reality, 2D and 3D interaction, and mixed collaboration. I mean by mixed collaboration, co-located and distant collaboration at the same time. We are also interested in the requirements elicitation and shared understanding via multi-view interactions. And of course, everything can be done if we are having a deep focus on the knowledge management and sharing, and what the actors are doing with the knowledge and how the knowledge is built during the collaboration. So why do we need observation? Observation as a research tool. Observation is generally considered as a valuable researcher tool when you need to articulate theory with practice. We'll see later what can be the posture of the researcher relatively to his research question. Here are some arguments that speak in favor of observation. Acquire empirical data on collaborative engineering situation is interesting when you have situations that won't rehearse or may occur but not so often. It is also interesting when you want to build a corpus for experiment analysis, and this kind of corpus can be processed by several means, multiple different actors, or as a basis for comparative studies. The third point is about capturing the evidences for further demonstrations and try to fix in time the elements that provided you with the hints for the research. Thanks to the new technology, we can observe that more than human can watch and listen, observe in real time. It encompasses the time, the space, and the multiplicity of media, and when you are alone observing this, it's quite difficult, and sometimes you are not able to do that. For example, in aside conversations or when the collaboration is mediated. And of course, when you have rapid interaction between actors, it's very often very difficult to keep trace of what happened. The concept we will develop further have been promoted in the doctoral seminar of the IDON. IDON stands for International Design Observatory Network, that already held 2 sessions. The last was this summer 2012. Well, now I'll give you some example of the research project we have done that involved observation previously. It should help you to identify the opportunities for designing an observation, and we will have mainly 3 types of situation that we will try to characterize. Any observation relies on a situation. It's very useful to start with identifying the elements of the situation in order to characterize it. So, in the first row, we will propose a model which is built on 3 main components. The design situation first encounter the task. The task is defined by the goal and the conditions of achievement. Next, we have the actors. The actors of the task are people that are participating to the design task. They are carrying, of course, various factors such as the knowledge, the skills they get, the social ranks, specific vocabulary, etc. that will impact the process. Third, we have the objects. By objects, we are meaning the elements that people will work on, the product they are designing, for example, or the service. It can be drawings, spreadsheets, digital mock-up, etc. Of course, everything is evolving in an environment, and there are mainly 3 aspects of the environment. The first one is the industrial environment. We also have the technical environment and the project environment. These factors will impact the situation. It can be, for example, some element of the domain knowledge that is mobilized during the design, the tools that has been used, the rules which are used in the industry, the schedule, organization, the floor layout, etc. This model is intended to be used for analysis and for existing situation, or to design a new artificial one. So these are the points we will go back further in order to define the situation. First kind of situation we will encounter is the control situation. Usually it's the kind of situation we are building for tools and method assessments. As we are working on engineering activity, we are bound to produce new methods and associated tools in accordance with the domain, the field, that we are prospecting and studying. Consequently, this tool or method have to be tested, evaluated, confronted to facts, users, and context. Hence, the input of such process is the tool or method that need to be evaluated. Whatever the deep reason is, it can be for marketing reasons, scientific publication, or industrial contract, anyway. So an inner process will help to define the assessment criteria, the kind of observation that is required, and the scenario that will involve the tool or the method we are assessing. The output is generally the result of this assessment. That kind of observation is very prescriptive. Among the task, the object, the subject, and the environments, we are trying to control and have hand on all the parameters of the experiment. That's why it's called controlled situation. As an example, here is a collaborative software we developed and we wanted to assess in real condition. It was a software for a distant collaboration platform involving multi-expertise design situations. The specific focus we had on this experiment was to study the private and public workspace and the dynamic between this space and how people were using it. On the other end, we had the uncontrolled situation. uncontrolled situation means that when we are facing, for example, a new situation, the researcher will need to get information on this situation in order to better see where he's putting his eye and trying to understand. So it can be thanks to the rise of new social practices, the integration of new technologies in the design process, or when very rare events occurs. From this need for investigation, researchers will try to collect empirical data. These data will be processed and analyzed, thus the researcher will be able to provide a reliable description of the situation. Furthermore, he'll try to output some relevant research questions based on the authenticity of the initial situation. That kind of situation are very close to ethnological posture, and the kind of observation we are making is very open. We don't have the control on the element, we are just benefiting from an existing situation. Usually, as it is hard to forecast what will be observed, observation settings tend to be very rich and complete in order to collect the maximum of available information. As an example, here is an industrial situation we observed a few years ago in automotive industry, bigger French automotive industry. It was during a distant project review. You can see on the left part of the slide pictures from the two distant sites. One was from manufacturing and the other one, Saint-Priest, was for the design team. The observation led to the corpus of an empirical data. You can see on the right part, upper part of the slide, the quad view with the different video and audio streams we get. Then, thanks to a further analysis, we were able to output some research questions around the argumentation in the situation and the collaborative writing of the report that was wrote during that kind of meeting. Usually, research in engineering are located in between the two previous types of research actions, the controlled and the uncontrolled. So here we are in the context of a semi-controlled situation. It means that some parameters will be controlled, but we may have to face free coupling, which are advocating for quite open observation. So it is a less prescriptive process. We will try in that kind of situation to put tools and methods in an open situation, and we'll study how the product and the usage will evolve. That's usually that kind of experiment we are doing. So level of control, you can see on the left part of slide, left hand, that going from the control to the uncontrolled, we are losing power and the control on the parameters. And in that kind of situation, we are in the middle. But the result can be partly the same between the assessment results and the research questions. The principle of this observation I'm showing you now was to try a new tool, not evaluate, but really to try a new tool. It was a collaborative whiteboard with annotating functions in a context of a project review. We defined a task and scenario implying roles for the subject. We consider that this is a semi-controlled situation because even though we defined quite precisely the situation, there were no hypotheses about the behavior of the subject or the interaction with the software. Hence, some parameters were relaxed and so considered. Here is the technical setting we used for that kind of observation with 2 rooms and the video flows, more the technical aspects. And the task definition here is a short design meeting scenario. So they are quite guided. It was about an innovative sled and there were 2 roles, and the observation gathered some element from video, the trace of the software that has been used, and of course we had also some feedbacks of the actors, the subject of the experiment, after the recording. Now that we have seen some practical elements on the previous research project where observations were held, we'll now focus on the process of designing the observation. This is not to be taken as a strict way of preparing the observation, but it gathered the main steps that should more or less occur while designing an observation. So we really want to show you now what we can offer as a visionary project for the TNA. Here is a proposal of design process for design observation. The process is organized in a sequence of several phases. It is based on a classical design process with the successive phases of planning, conceptual design, detailed design, prototype, and implementation. The first one will correspond to the research question and the research plan. The next one, the second one, is the conceptual design of the observation. The aim is to define the main concepts of the observation framework, of the design situation, and of the metric and instrumentation. The third phase is dedicated to the detailed design of the same elements. The prototyping phase will hold pilots, and in order to test and adjust elements, hypotheses of the design of the observation. It is facultative, but usually run in order to enhance the quality of the main observation. Finally, the main observation is run, and further steps encompass coding of the dataset and the analysis of the data. Visionaire will mainly provide service in the design and the implementation of the observation. That is marked with the red bar at the bottom of the slide. However, help will go beyond these strict limits in upstream and downstream, helping you to get your research question and define the best observation, and giving you the tools and the methods for coding and analysis. So let's go in more detail on this process and start with the very first phase related to defining the research question and the research plan. Guests are submitting their project with a rather clear objective. There are different epistemological postures a researcher can have to carry on a design observation. Depending on your posture, you might want to test a pre-existing theory thanks to the experiment, or on the contrary, observe a situation to eventually build a theoretical model. Obviously, many choices and strategies in the design of the observation are closely related with guest research objectives. Do they want to use visualization facilities to validate a theory or an hypothesis? Do they rather intend to explore or even to identify new questions about visualization? The key issue at this stage of the design process is to have a clear view on your research question and to formalize it. This will give clear orientations for all the following process. In addition, you have to define the status you want to give to your design observation. Should it be an explanatory observation, a case study, or an experiment? Or should it be a quasi-experiment or even an experiment? Of course, this choice will have some impact on the replicability of your observation and on both internal and external validity of the result you will get. Among the questions we'll ask the visitors, we'll want to have and to highlight what are the relevant features that are observable for your question. We will want to know how to observe and define how to observe and capture them, and the type of analysis you are thinking about for this observable and what you want to produce in order to answer your question. In the very beginning of the process of designing the observation, you have to ask yourself what can be observables. Among the questions we'll ask the visitor, we will want to highlight what are the relevant features observable for the research questions. And of course, how to observe and capture them. The type of analysis you are thinking about also will have an impact on the corpus we will build, the video we will need to assemble, the conversation analysis we will have to draw, etc. And of course, the resource needed. Here are some kind of questions that can be asked during this phase. The answer is not straightforward, and the apparent duality of the question is an illusion. Due to the the visualization constraints, we are not able to propose a fully natural setting. We could say in the wild. However, we try to rebuild the environment as close as they could be in the real life, so it will be a contrived setting, but not totally contrived. Usually, subjects are aware of their status. They know that they will be observed, but the settings try to be as less intrusive as possible. So we could rather speak about a non-disguised observation. About the human versus mechanical observation, it's rather a mix. Well, we will help and propose, for example, to have complementarity between the human aspect of observation and the mechanics provided by different technical devices we are using. Humans can focus, for example, dynamically on a specific phenomena, while the mechanic can only trace what they were intended to. Both direct and indirect observations can be held. It is usually a safe way to ensure redundancy and cover the range of clues that a single type of observation could not ensure. So, main difference is if you want to observe directly what is done or what is the product of what has been done during the process. More or less, structuration really depends on the type of research you are doing. Open investigation or tool assessment will lead to different structuration of the observed element. After formalizing the research question, clarifying the posture, your key assumption, and the theoretical background, the second phase of our design process is the conceptual design of the design observation. It consists in a co-definition of the observation framework, of the definition situation, and of the metrics and instrumentation at the same time. Let's start with designing the design situation. We already talked about the design situation and the model we are using. For that phase, we'll instantiate the situation model that we described previously. Firstly, we'll define the task, and you have to define what complexity of the task you want, what representativeness of the task. Is it a simple task, very reduced, it can be easily repeated or also rapidly analyzed? Or is it a more complex task that can be very representative of an actual design task in industry? What are the steps of the task? Do you split it in different phases? You also have to define the actors. The actors, depending on the target population, are they students, professional designers, and how many of them would you want to have during the experiment? In case of an experiment, you have to choose them randomly among the selected population. In the other case, you have more freedom to define groups of participants by their skills, for example. You will have to adapt the environment characteristics. If we concentrate on this environment, you will have to define the observable and the potential measures and to imagine what are the required equipments that allow to observe and to capture these elements. And of course, once you have defined this, you have to define the location of the element, the devices that you will use for the capture. The second main element of this conceptual design phase is the definition of the observation framework. So during the observation framework, we will have to define the timeline of the observation, the groups that we want to involve. Do we want to have several groups to compare, for example, or we don't need any reference? And the main steps. Just an example. Here is a classical framework that we propose. It is composed of 3 steps. The preliminary steps generally refers to training, interviews, warming session, and preparation task. Everything can allow to prepare the designer or the group to master the tools that will be used in the design task or to start a common work. Then, in the main task, the design task itself, we have to design and capture. The concluding step can involve interviews, debriefing. We can also have self-confrontation between the actors and the subject of the experiment, with the video also, for example, or with the results. It can also consist of some closing task in order to produce some more design outcomes. The last elements of the situation we need to define is the metrics and instrument. Metrics are chosen according to what you want to measure. It's directly related to your question research and the observable that makes sense for your issue. The concept of the instrumentation have also to be defined. For example, whether the activities have to be video recorded or just audio recorded. The level of information you need. For example, will you go for a general computer screenshot or just audio recorded because you think it's enough for what you want to do? It could be also which window you are opening, or do you need a monitor? For example, if we are considering a computer screenshot, and the resolution will impact, of course, the ability to observe what you get as an output from the observation. So if you want, for example, to be able to see the text that is typed in the window, you will go on a different device than if you just want to have a bigger view on the overall screen. So the capture here is mainly about the intermediary object, which are very often useful, and it can be also mail, chat utterances, etc. About running a pilot, prototyping is a key issue, even if it's not always possible. Project schedule should keep room for running a pilot. It's a true source of improvement. The first observation allows to validate some of the hypotheses you have made during the design of your observation. This is also an opportunity to improve some elements, check the settings, monitor the quality of the observation, of the observables, etc. So, running a pilot often leads to go backward in the design process in order to make some adjustments in the definition of the design situation, and sometimes also in the metrics and the instrumentation. The central point of the project is to implement the observation. Live performance, where we can still discover some elements of our behaviors that we did not expect. Hence, handwrote notes, real-time monitoring, thanks to the one-way mirror you can see on the picture on the slide, and sound feedback can happen. Last-minute changes or orientation of the experiment can be done during this phase, thanks to the ability to watch and monitor in real time what is happening, especially if the task and the scenario was built on conditional basis. The next step will consist in structuring the corpus. Structuring the corpus will consist in mounting, for example, the video flows and the audios to transcribe the verbal and gesture interactions in order to facilitate the analysis, to apply your coding scheme defined previously, to annotate also the videos and the important moments and events that you have seen in the videos, and to also solve the coding conflicts when you have different people coding the same parts in order to make it more reliable. According to the objectives of the guest, analyses are driven in order to produce the results that are expected. It can be a model, or validate or not validate a new hypothesis. It could be a performance assessment. It can be in order to define new patterns of activity, or define new collaboration criteria, etc. As a conclusion, you may have seen that we are developing some observation for research in the field of engineering and collaborative environment. So it's mainly about engineering, but we can also open, of course, that kind of observation to different fields. What we have to get from this presentation, to keep from this presentation? First, designing an observation is a complex process to organize. That's why we proposed a process, a very well-defined process that may help not to forget the main steps and main items we should handle during the definition of the situation and the observation. We need also to conduct a thorough analysis of what the guest, the visitors, will need. According to its question, we need to fit the best possible with his needs. It implies also to deal with the uncertainty of any human activity. And as we will involve human in the observation, we will have also to take into account the fuzziness of the activity, even though we are in a controlled situation. We also need to take into account the expectation to provide a valuable set of data that will meet the research requirements of the visitors. Of course, we can extend this to any kind of human interaction that will involve visualization, because as you may have seen at the beginning of the presentation, we are working here with collaborative environments, so that's the kind of device we can propose as a support for the observation. Thank you for your attention, and hope to see you soon in Grenoble for some observation. Bye-bye.